Welcome to the demo video of the tool Code2LowCode for the Models 2026 demo paper. So in this project, we can basically here create a new project. I will call this Models 2026 demo. Then we can here upload the source code we want to analyze. Therefore, I prepared a zip archive. Then we could here add some more domain knowledge, add some fragment extraction, like whole file fallback extensions for files that cannot be parsed, like a JSON or a YAML in this case. And then here we can basically start to configure our pipeline, starting with the classical detectors, ML-based detectors, and here the LLM-based detectors. Then here we can basically configure the whole pipeline, and here we can add the LLM configuration or change the LLM configuration. Then we can run the pipeline. So all the code fragments pass through classical detectors, embedding detectors in this case, and then the LLM detectors, which here we can see that the embedding discarded 57 potential co-clones as non-co-clones. And here we can see the result, where we can basically see which code was regarded as a co-clone, from which detector, which type it has potentially, and which similarity score it has. Then we can basically now could start the abstraction chat, and therefore I prepared another project with 3 SCL files, which is basically code for PLC automation. I already did run the pipeline, and all of 3 of those files were detected as co-clones. Then we can basically start the abstraction chat, where the LLM gets the co-clones as context and is also able to basically just read the files, and then it starts to see, okay, what is common, what is not common, and how can we best abstract for this, where it also gives the reasoning, and in this case it proposes a state machine DSL with like the antler, like another tool for language recognition in this case, and then it basically creates an artifact and also gives an example of how this could be used to basically create one of those files. And it also gives like, okay, next step, what do we need to discuss and so on, which we can basically then add here in the refinement chat. Like after reviewing basically does create an artifact, we have basically the opportunity to change something. In this case, change the naming, for example, to PLC flow. And we could also add more domain knowledge, like let the LLM basically refactor most of this stuff. And then after the request, the LLM creates the next artifact. In this case, it is renamed PLC flow. It will create basically the same artifact. And then now we as an engineer have again the opportunity to review this artifact. And if we're happy with it, we can approve it. And after the approval, we can go to the code generation, where we here again can basically set up the LLM. Then we can select the target. In this case, we only have the antler grammar available. And then we can start the code generation, which works as an agentic loop, where we basically generate the code, validate the generated code with some MCP tools. In this case, we try the grammar, like is it parsable or not, and then the result of the tool is basically incorporated in a feedback loop, and the LLM will try to fix potential errors. Now we can see the first round of code generation finished. It did validate, but the validation failed, so the LLM will now incorporate the feedback of the tool and start generating the code again in a second iteration. Yeah, now the iteration finished again, and as the validation succeeded, the LLM now generated basically DG4 files with an example, which we can basically edit or download and then incorporate